we want to be able to convert between a polar function and a rectangular function. And this could be useful for a few different reasons. It could be useful just so that it's a more familiar format for us, or it could be useful for other reasons also, just if we want something in terms of x and y instead of r and theta. So some formulas that will be useful for that. We talked about these yesterday. We have x equals r cosine of theta and y equals r sine of theta. And then we have the Pythagorean theorem, r squared equals x squared plus y squared. And the tangent of theta is y over x. And this is actually going to be useful also. This actually gives us a slope in a sense, and we'll talk more about that later. But remember, slope is the change in y over the change in x. So when we have y over x, there are some cases where that's actually going to give us a slope of something. So these equations all come from the triangle. If you remember, what we did is we drew a picture, and we had for a point at r comma theta, where this angle right here is theta, and the distance here is r, we drew a right triangle, and so we got coordinates, we got relationships in this triangle by using this right triangle here. So the sine of theta is y over r, and then we solve for r to get, we solve for y to get this, and so on.